Okay, for logistic regression, I'm going to do this in two videos. We'll talk about what it means, as well as start an example, and then we'll use the second video to finish up and to do some model fitting. So this first thing, what this is a picture, if we only had one independent variable, the difference between linear regression and logistic regression. Linear regression is when we assume that the y, the response variable, y, is continuous, and so what we get when we do linear regression is we get the blue line. We get this straight line that once it's selected can go forever this way, forever this way. Logistic regression is when our y variable is either 0 or 1. So it's like getting a cold or defaulting on a loan. The outcome is 0 or 1. So what logistic regression gives you is a probability. It gives you a likelihood, a number between 0 and 1 of the likelihood of this occurring or not. So when you draw a picture of that, you don't want to use the blue line because the blue line can be negative and it can be bigger than 1. We don't ever want to use regression because it will generate a number sometimes bigger than 1 and less than 0, which doesn't work. You want the probability to take into account, and what that means is that when you use logistic regression, your probability curve looks like this orange line, where when the likelihood is very small, it bottoms out at 0, and then when the likelihood is really high, it ceilings or tops out at 1. Now, again, it doesn't tell you, it gives you a probability. So you can see that there's going to be a break point where it's not going to happen, and then all of a sudden there's a decent chance it happens, and then up here it definitely is going to happen. So it's just giving you a probability, and generally what we do is that we pick a cutoff point, generally at 50%, and then when we generate a probability that's less than 50%, we say it's not going to happen, and then when the probability is bigger than 50%, we say it's going to happen. It does not have to be 50%, it can be anything you want, but that's generally what we do. So that's what we do in logistic regression. How do we come up with this probability function? So some terminology. If you notice what happens, this equation of a line shows up like this. It looks a little bit like this. There's your a plus bx. That's your equation. That's your equation. We call that a logit. It's called a logit. So how you calculate the probability in general is that you take e, the natural logarithm e, that 2.71 something constant, and raise it to this. That's in your numerator, and the denominator is 1 plus e raised to the logit, or this regression equation. So let's start an example, and here it is. We're looking at people that are buying a house, and we have historical information on did they buy the house or not. So there's some times when they did not buy the house, and then sometimes when they did buy the house. And we looked at that, and we looked at three things. We looked at what the income of the person who was considering buying the house or not. We looked how old they were, and we looked at where the house was, what zip code was the house located. And we only have 2 zip codes. We got 1 and 2. Probably ought to use 0 and 1 instead of 1 and 2. In fact, let's just do that real quick. Equals if this equals 1, we'll say 1, else put 0. So this will be our dummy variable. Copy, paste special. So I'm quickly I went ahead and converted this. I took these 2 zip codes and just turned those into 0s and 1s. So we've got, this is a certain zip code and this is another zip code. If we had 3 levels, we would have to have 2 dummy variables. So no different than what we covered before. But here's the data. Did they buy the house or not? This is their income, how old they were, and where was the house located. And it's either in one neighborhood or one zip or the other zip. And I want to build a regression equation, a logistic regression that predicts the probability that someone's going to buy a home based on these different choices. So that's the data. Now, what I have over in this logistic regression is it's a template already built. You can use it for free. Just really you all have to plug everything in. So the very first thing I did is I took the data and I copied it over here. Let's go ahead and copy the zip code correctly. Like that. Okay, so there's the zip codes. Now, so here's the data, and it goes down forever. You can make this as many data points as you want. These are going to be my regression coefficients. There's the intercept, and this is the coefficient for income, this is the coefficient for age, and this is the coefficient for zip code. The rest of this is things that you don't have to touch, but let me go ahead and go through it. The very first thing is the logit, which is just the regression equation where I take the sum product of these against these plus the intercept. So that's what this equation is. It's the intercept plus the sum product of the regression coefficients against the input. So every one of these has is value, and you can copy that down. Then from the logit, I use this equation to calculate the probability that they purchase the house, so that's this formula. And if you see what it is, it's E, which you can, in Excel, it's EXP of the logit in the numerator, and then divided by 1 plus the logit, 1 plus E raised to the logit in the denominator. So this is the probability that they're going to buy a house. Then this next column is the probability of this occurring. So this is the probability that this is equal to 1, but if I'm trying to figure out the probability that they got it right, in this case, the purchase was a 0, so rather than this one, I want to do 1 minus that. So the probability that the model says that they are not going to buy a house, which is 0, is this value. And all that is, it's an if statement. If this is 0, if this is 1, just get it, otherwise get 1 minus. So you can see that these are all zeros, so these are all 1 minus these values. But this one, they actually purchased it. That's the probability, and that's what we're trying to predict. We just bring it over. So again, you don't have to touch that, but I'm walking you through. Now, what we want to do is take the product of this. We want to take this times this times this times this, and the product of all of those probabilities we're trying to make as big as possible. We want the probabilities, and you don't want to add them up, you want to multiply them. This times this times this times this for all of these. Well, and then I would try to maximize that probability. Now it's going to be a really small number because we're taking a bunch of numbers less than 1 and we multiply them together. And we're trying to make that as big as possible. So here's a trick, here's a math trick that they use. Rather than multiplying these together, they take them and take the natural log of these. So we take these probabilities and we take the natural log of all these. And again, all you have to use is ln of that function. That's it. That's all you have to do. But rather than multiplying all of these together and maximizing that, we can add these up. And that's the beauty of this thing. Rather than we take this plus this plus this plus this all the way down, if we sum that, that's what we try to maximize. The sum of these, they're called log likelihoods. So rather than trying to figure out and take the product of all of these, which we could, that's legit, we could either maximize this, but this becomes such a small number, it's hard for optimization to work well on it. Rather than trying to maximize that, we try to maximize the sum of these where we converted these to something and we can add them up. And then I've got a 50% cutoff and I just want to know if it's right or not. And all I'm doing is I'm looking at this probability of success that the model chose what it was, and I just keep track. If that number is bigger than 0.5, then I correctly chose it. So in this case, the probability that they didn't buy the house was that they bought the house was 2%. The model says probability that they did not buy the house is 97%, which is bigger than 50%. So this is a correct prediction based on these coefficients. Okay, that's what this is, and I've got over here where I'm just counting how many times I got bigger than, I got a 1, which was my percent correct. Now, the trick is, how did I get these coefficients? Well, here's how we do it in Excel. This is not probably how you would do it otherwise, but in Excel, what we're going to use is optimization. We're going to use solver. We're just going to tell Excel, you have control over these numbers. You have control over these, and you change what these are to maximize this. And I've already got that set up. So if you go to solver, it's that simple. You're taking this value and making it as big as possible by changing these values. So let's put these back to 0. This is basically having a model that doesn't have anything, so it gives a probability of 50%. You can't look at that. They're all sitting at 50%. And I want the model to say, what should these coefficients be to maximize my likelihood? Now this number is always negative, so you're just trying to make it as close to 0 as possible. So I'm going to go to solver. I'm changing these values by doing that, and it's a nonlinear, so leave that nonlinear, say solve. And it says it converged to the current solution, which is sort of saying it's solved. And what it's saying is that these are what the coefficients should be. There's what it made that number as big as possible, as close to 0 as it can. And this is the logit, and you can see in this case we've got 81% correct. We correctly produced, and you can look at these numbers. So this person here, or this person who bought the home, the model said, I mean, if you look at these, this person did not buy the home, and the model said they're not going to buy it, and it's a 98% chance. Now this is a mistake. This one, this person actually bought the house. The model said there's only 11% chance of that's occurring, so the model didn't get that one right. The model's predicting 0 because the likelihood of purchasing is really small, so it predicted not to do it. Well, it's a mistake. This is what really happened. So you didn't get 100% correct, and our goal is to try to make this as big as possible by maximizing this log likelihood. Okay, that's the first video. I'll do another one because I want to do model fitting. I want to know which of these are the most important, and how do we go about looking at how important these are. And I'm going to give you a technique using this stuff here. Okay, thanks.